All right, we'll continue with our graphing, and both of these are already in our y equals mx plus b form. And so we start with the first inequality. We have a negative 2 y-intercept. So I plot my point right there. A slope of 1. So I know up 1, right 1, up 1, right 1, on and on. Or down 1, left 1, down 1, left 1. It's going to be a solid line because of the greater than or equal to symbol. So here's my line right there. And then as far as shading, 0, 0 is not one of the points, so I can test 0, 0. And is 0 greater than or equal to 0 minus 2? Well, that would be 0 is greater than or equal to negative 2, which is true. And so I'm going to shade the region of the graph that includes 0, 0. So remember, 0, 0 worked, this point right here, so I shade the region that has that value. So I'm shading everything above. All right, and now go to our second one. Now we're at a y-intercept of positive 2, and I have a slope of negative 1. So down 1, right 1, down 1, right 1, on and on. Or up 1, left 1, up 1, left 1, up 1, left 1. It's only less than, so it's going to be dashed. And now, again, 0, 0 is not part of that, so I can test 0, 0. And is 0 less than negative 0 plus 2? Well, that all equates to 0 being less than 2, which is good. So again, this is one where 0, 0 did work, so I shade the region of the graph that included 0, 0. For this dashed line right here, 0, 0 is everything below that. So right away you can see where my blue and yellow are making green, and I get the appropriate region of the graph. So all that green area is my solution. All right, on number 8 we see something we haven't really seen yet. The first inequality is in standard form. We have seen that. But the second inequality, it's not in y equals mx plus b form, and it's also not in standard form. But we'll come back to that one in a second. Let's look at the first one, standard form. Remember, when something's in standard form, we don't know the slope yet, and we don't know any intercepts, but what we can do is easily find the x and y intercept. So the x-intercept occurs when the y value is 0. And so I set it up to be equal to 6, because that will give us our actual x value of our x-intercept. So 3 times 0, they just cancel. We're left with 2x is less than 6. Divide by 2 on each side to isolate the x. And then x equals 3. And remember, that gives us the x-intercept of 3, 0. So I can plot that point right now here at 3, 0. And then for the y-intercept, well, the y-intercept occurs when the x is 0, so I make the x 0. That gives me, those cancel. I'm at 3y equals 6. Divide by 3 on each side, y equals 2. That gives me the point 0, 2. So there's that. And because it was only less than, not less than or equal to, it's going to be a dashed line. So we'd have something along the lines of that. But now we get to the second inequality. And so I'm going to rewrite it down here. Y minus 1 greater than or equal to negative 2x. And it looks a little weird because it's not in y equals mx plus b or standard form. But I can easily add 1 to each side of the inequality. And now what I'm left with is y is greater than or equal to negative 2x plus 1. And now there's my slope-intercept form that I'm used to. So I can go to plus 1 on my, actually, sorry, let me back up. Let me go really quickly shade this one first. Let's shade that one. I forgot to do that. And so on this one, if I test 0, 0 for this one right here, I'm going to test 0, 0. That means 2 times 0 plus 3 times 0 less than 6. Well, that would be 0 less than 6, which is true. So now the region of the graph that includes 0, 0 is where all the solutions lie from my first inequality. So I shade all that in. Okay, now let's go back and do the second one. So y is greater than or equal to negative 2x plus 1. That's a y-intercept at plus 1. My slope is -2, so that's down 2, right 1, down 2, right 1, down 2, right 1, or up 2, left 1, up 2, left 1. And this one is a solid line because of the greater than or equal to. So there's that. Again, 0, 0, not part of the line. So we can go ahead and test 0, 0 here. Is 0 greater than or equal to -2 times 0 plus 1? That would be 0 is greater than or equal to -2 plus 1, which then gives us 0 is greater than or equal to -1, which is true. So again, the 0, 0 region does work for this graph. So the solid line I just made, 0, 0 is right here or below the line. So now I'm shading all of this, and based on where these lines were located, we get a pretty large green area. And that represents. Now notice this little sliver up here of blue, that's not part of the solution. It's only where the yellow and the blue overlapped. Okay? All right, so now we're going the opposite direction. What if the shaded graph is already all done for us? We can see that there's a darker area right here, and that represents all the solutions. The question is, what are the inequalities for the two lines that are drawn? So let's start with this horizontal one right here. We know that there is a y-intercept right here at 3. We also know it's a horizontal line. Now the question is the shading above or below this line? Well, because of this white region up here, this unshaded region, I know it wasn't shaded above the line. It had to all have been this shaded region below the line. So this first one is going to be y. It's dashed, so it's only less than or greater than. Well, this one, because I shaded below the line, is less than 3. That would be this inequality right here. Now for the vertical line, clearly that goes through where x is at 2. And then again, because of the unshaded region here, I knew that it couldn't be to the right of the line. It has to be all the region left of the line. So that's going to give me the inequality x is less than 2. Because it was dashed, I know it had to be only less than or only greater than. So those are the two inequalities that represent this graph. Okay, number 10. Now you look over here. This lighter one's a little hard to see. It is dashed. You can see the dashes, but I know it's a little difficult, but they are both dashed. And then what we have is they're shading over this entire graph. Well, how could there be shading over the entire graph? That could only happen if we're above one of the lines and below another one of the lines, and then they overlap right here. So you can kind of imagine, okay, if I shaded everything below this line, that would be all of this below. And then if I shaded everything above this line, that's all of this. And then you have this little horizontal section where they overlap. So they're both dashed and they're both horizontal lines. I have a y-intercept here at 3, and we knew that we shaded everything below it. So that would be y is less than 3, just like it was over here. You can now look at these and say, oh yeah, I see the similarities. Y is less than 3. And then for this horizontal line, we're at a y-intercept of 1, and we shaded everything above. So that would be y is greater than 1. And that's what would produce this darker shaded section right here. If I was above where 1 is, but if I was below where 3 is. It gives us this boundary section right here. Okay? Now these ones were not bad because it was only horizontal or vertical lines. Well, now we're going to get to our diagonal ones. And just use what we know. We're going to talk about y-intercepts, and we're going to talk about slope, And we're going to pay attention to whether it's dashed or solid, and then shaded above or below. So the first thing we can recognize from this graph is we have this entire region right here that is unshaded. It wasn't shaded at all. So I can just visually see that where this dash line is, I can't shade everything above it because that would include this region right here, which is not shaded. So everything below this dash line had to be shaded. And then similarly here, I have the solid line. It had to be all the shaded region up here. And then here's the darker region where they overlapped. Okay, so let's start with the dash line. We have a y-intercept at 1. And to get from one point to the next, to the next, to the next, I had to go down 1, right 1, down 1, right 1, down 1, right 1, which is a slope of negative x. So I know I have a y, I have a slope of negative x, and I have a y-intercept at plus 1. The question is, what is my inequality symbol? Well, I know it's dashed, so it's either less than or greater than. Well, when I look at this shade or this dashed line here, if everything below it is shaded, think below less than, below less than, below less than. So I would do that. And then for my second equation, I actually have the exact same y-intercept, so that's plus 1. And now, to get from one point to the next, to the next, to the next, it was up 1, right 1, up 1, right 1. So that's a slope of positive 1x. And now the question is it less than or greater than? Or less than or equal to or greater than or equal to? Well, it's solid. It's a solid line, so I already know it's equal to. But now, do I put a less than or greater than sign above that? Well, now all the shading for the solid line is above. So now think above, greater, above, greater, above, greater, and you end up with that. Those are your two inequalities that represent that shaded graph. All right, now the last one. And this is from highlighting on the other side, so just try to ignore that. We see that we have two lines that appear to be parallel, and again, the whole graph is shaded. So that could only happen if I was below this one and above this one. So if I was below this, it would be all this area right here. And then if I were above this one, it'd be all this area right here. And they would have that overlapping channel, okay, with one being below and one being above. So let's recognize our y-intercepts. This is at 1. This one's at -2. So I already know I'm at a plus 1 for the first inequality, y-intercept. To get from one point to the next, it's down 1, right 1, down 1, right 1, down 1, right 1. So that's negative, a slope of negative x. It's only going to be greater than or less than because it's a dashed line. Well, remember we talked about how the shading is all below this one. So that would be my less than. Now the last one, we have a y-intercept at -2. It's the same slope, down 1, right 1, down 1, right 1. So that's a negative x. And now this one, all the shading was above. So again, think above, greater than, above, greater than, above, greater than. And there are your two inequalities there. And so as you look at these ones, when you get to your homework, recognize where must the shading occur for each line. Is it above or below? And if you determine, oh, the shading for that line was above, that's greater than. If the shading for a line is below, you think less than. And then if they're solid lines, just add a little equal symbol below the less than or greater than. Okay? So good luck with your homework.